Hey there, in this video I'm going to talk about how to balance equations. And the reason that we have to balance equations is because of the law of conservation of mass. And the law of conservation of mass says that we have to have an equal number of atoms for each element on each side of the equation. So if I have lithium here, I have to have the same number of lithium atoms on this side of the equation, which on the left side of the equation represents my reactants, as I have on the right side, which in this case, it's just a single product. There can be one, there can be more. So one of the rules with balancing equations is we can't change the formula. For example, the formula for lithium chloride is LiCl. And the reason it is because Li has a +1 charge and Cl has a -1 charge. So with opposite and equal charges, that makes the formula for lithium chloride LiCl. So we cannot change the formula by adding subscripts or anything like that. So that's not allowed. The only thing that we can do is add coefficients. And a coefficient is a whole number placed in front of a substance that multiplies through. For example, if I have the substance water, H2O, and I put a 4 in front of it, usually the 4 would be drawn a little bit closer, that 4 multiplies through, and now we have 8 hydrogens, and we have 4 oxygens. Before we had that, it was just 2 hydrogens and 1 oxygen, but putting that 4, that coefficient, in front of this equation, or this formula, tells us that we have 8 hydrogens because it multiplies through, it doesn't add, and 4 oxygens. So a coefficient is a whole number and it's placed in front of substances. So the first step in this is doing an atom inventory. So what we do is we actually just list the elements involved. And on each side of the equation, I'm writing down that I have lithium and chlorine. And now I count. I have 1 lithium, I have 2 chlorines on the reactants side, and I have 1 lithium and 1 chlorine on the product side. The goal is to have equal numbers of each element. Now, if you look at the lithium, you can see that there is 1 lithium on each side, so that element is not of concern right now. So I look at the next one, and I see that I have 2 chlorines and on the reactant side with 1 chlorine. Oh, I'm sorry, a little yawn. With 1 chlorine on this side. Now I need 2 chlorines on this side. So the only way I can get 2 chlorines on the product side is to put a big 2 in front of this whole formula. Now that I've done that, I have to update my changes. So now that I've done that, I no longer have 1 lithium, now I have 2 lithiums. And after I have put that coefficient there, after I've made the changes, I'm updating my atom inventory. Now I have 2 chlorines. So my chlorines are equal to each other, but now my lithiums are not. I have 2 lithiums on the products side, and I've got 1 here. So there's a simple solution to that. If I put a 2 there, that will give me 2 lithiums on each side and 2 chlorines on each side. So we'll do the same with letter G here. We have 2 elements. We have hydrogen and nitrogen. So I'm doing an atom inventory, hydrogen and nitrogen, and the first step is just to count. I have 2 hydrogens here and 2 nitrogens here. Here I have 1 nitrogen and 3 hydrogens. Now I have to tell you that a strategy that I use when I'm balancing equations is if I ever have an odd number of something on one side and an even number on the other, like this 3 is 3 hydrogens on one side and 2 hydrogens on the other, a good strategy to do is to just go ahead and double whatever element has the 3 atoms. So my hydrogen has 3. And I could also look at this another way. I could also be dealing with nitrogen. So I have 1 nitrogen here and 2 nitrogens there. So I can respond to this by putting a 2 there. And when I update my atom inventory after I've made this change, now I have 2 nitrogens and I have a total of 6 hydrogens. This 2 multiplies with the 3, so it's not 5. A common mistake is to add them, but it multiplies through. So there are 2, the coefficient is 2, it multiplies through to give us 6 hydrogens. So now my nitrogens are equal, those are good, and my hydrogens are not. So on the product side, I have 6 hydrogens and I only have 2 on this side, so what I can do is put a 3 there. And now I have 6. And now this one is balanced. All right, I'm going to do 2 more that are a little bit more complicated. The first one is called a combustion reaction. And a combustion reaction can be recognized because you have some sort of hydrocarbon. So you have 2 elements here, carbon and hydrogen, combining with oxygen to make carbon dioxide and water. And in a combustion reaction, a strategy is to do your carbon element first, your hydrogen second, and your oxygen always third. So I'll set up my atom inventory like that as well. On the reactant side, I have 3 hydrogens. Oh, I'm sorry, 3 carbons. I have 8 hydrogens and I have 2 oxygens. On the product side, I have 1 carbon, 1, 2, 3 oxygens, and 2 hydrogens. So if I'm dealing with carbon first, so this is my strategy, carbon first, hydrogen second, leaving oxygen always for last. In fact, a good rule of thumb when you're balancing equation is to save oxygen for last. It oftentimes helps. So I'm dealing with my carbons first. I have 3 right here, and if I put a 3 right there, now what I can do is update my atom inventory. Now I have 3 carbons. I still have 2 hydrogens, and I have 6. So 1, 2, 3, 4, 5, 6 oxygens plus the oxygen there is 7. So my total of oxygens is 7. All right, now I'm going to deal with my hydrogen next. I have 8 hydrogens on the reactant side, so I will put a 4 right here, and then I will update my atom inventory. Now I have a total of 8 hydrogens, and I have 6 oxygens right here, and now I have 4 oxygens over here. So my total of oxygens is now 10. So with my carbon and my hydrogen balanced, all I have really left to deal with is this oxygen right here, which is why it's handy to save it for last. So with my 10 oxygens here, with 2 oxygen atoms here, I can turn this into 10 by putting a 5 there. And that is how I can balance that equation. On this one, you have to be really, really careful because you've got oxygen in this part and also this part. So that adds a little bit more challenge to that type of reaction. I'm going to do the reaction on the bottom because this is a good example of where some things get repeated. And my elements include sodium, oxygen, hydrogen. This hydrogen can be located in both substances. And then I have sulfur and I have oxygen, which is a repeat. So I have a total of 4 elements. And I'm going to put them in the same order on this side so that they line up with one another. And I'm just going to count for my atom inventory. I have 1 sodium on this side. My oxygens, I have 1, 2, 3, 4, 5 oxygens. I have 1 hydrogen, 2, 3 hydrogens, and I have 1 sulfur. Okay, I hope I don't make any mistakes on this. Sometimes that happens and it's embarrassing, but we're all human. All right, here I have 2 sodiums, 1 sulfur. So, whoops, 1 sulfur. I have 1, 2, 3, 4, 5 oxygens. And I have 1, 2 hydrogens. So the element that I'm going to look at first is my sodium. With 2 sodiums on this side and only 1 on this side, I'm going to put a 2 here, and I'm going to update my inventory. Now I have 2 sodiums, and I have 1, 2, 3, 4, 5, 6 oxygens. And I have 1, 2, 3, 4 hydrogens, and I still have 1 sulfur. So my sodiums are now equal to each other. My oxygens are still off. My sulfur is equal. I'm going to deal with my hydrogens next. I have 4 hydrogens on my left-hand side, only 2 over here. If I put a 2 here, that will give me my 4 hydrogens, so I'm going to update my inventory. Now I have 4 hydrogens, and I have 1, 2, 3, 4, 5, 6 oxygens. And it looks like now my equation is balanced. I have 2 sodiums on each side, 6 oxygens, 4 hydrogens, and 1 sulfur. A common mistake for students to do